All right, we are going to be talking about the distance formula again. Okay, so let me just remind you that the distance formula is right here. This is the formula we're going to use for finding distance between 2 points on a graph. All right, so let's do some practice. We have 2 points. T is 5, 2, and R is 4, 1. So we're going to find the distance between the two. So I'm going to graph those. So I'm going to go to 5, 2, put a dot, and 4, 1. Okay, that's a very short line. So there's my line. I want to note the distance. All right, so you could use the Pythagorean theorem for this, but I want you to use the distance formula just to practice for this whole lesson. So we're going to start off by writing the formula. So the square root of x2 minus x1 squared plus y2 minus y1 squared. So here's our formula. Now, remember when we have 2 points, we're going to call one of them x1, y1, and I'm just going to label it right above. And the second point is going to be x2, y2. So, I'm going to replace all of my letters with numbers. So, my x2 is 4. My x1 is 5, and I don't know why I put a comma there. That should be minus 5. Let's square that. Plus y2. Y2 is 1 minus y2 is 2. And we're going to square that. All right, so the distance is equal to the square root of, now we're going to do parentheses first. So 4 minus 5, that's actually negative 1. Make sure you have parentheses around that. And we're still going to have the squared. And then we're going to do 1 minus 2, that gives us negative 1, and we're still going to square that. All right, so now we're going to focus on the exponents. So negative 1 squared, that's like negative 1 times negative 1, which would be positive 1. Again, negative 1 squared is positive 1. So 1 plus 1 is 2. So the answer to this is the square root of 2. Now it does ask for the nearest tenth, so I'm going to take my calculator and I'm going to actually calculate the square root of 2. Whatever that long answer is, you're going to write that down. So 1.414213562, that whole answer, and then you're going to round. So we're looking at nearest tenth, so that's the 4. The 1 tells the 4 to go or stay the same. So my distance is approximately 1.4. Remember, the squiggly equal sign is the approximate sign. All right, let's try another one. All right, example 2 says, let's find the distance between P and Q. So I'm going to graph those points real quick. So negative 3, negative 5. I'll put my first point at negative 3, negative 5. And then negative 4 and 6. All right, so this is the line that we're talking about. All right, so we're going to actually use the distance formula, though. So distance equals, let's start by writing the formula down, x2 minus x1 squared plus y2 minus y1 squared. All right, so let's replace our values. Now, before I do that, I'm going to label this one x1, y1, and this one is going to be x2, y2. So x2 is negative 4 minus x1 is negative 3. My y2 is 6. And then my y1 is negative 5. So you're going to take your calculator to do this math. Don't try to do this on your own, but we're going to type into our calculator negative 4 minus negative 3, which is negative 1 squared, plus, now I'm going to do 6 minus negative 5, which is 11 squared. All right, negative 1 squared is 1. 11 squared, you can do that in your calculator. 11 squared is 121. Add them together, you get 122. It does not say to round in this one, so we're going to actually leave it in square root format. That's our called exact answer. So we're just going to leave it when it doesn't tell us to round. All right, example 3. It says let A which is 4, 3, B, which is 1, 4, and C, which is -2, -5, be 3 points on the plane. So it says sketch the triangle on the coordinate plane. So let's do that. So we're going to graph the point 4, 3, that's our point A. 1, 4, that's our point B. And C will be -2, -5. Okay, I'm going to draw our triangle. Okay, part B says let's find the length of each side of the triangle. All right, so there's no straight lines right on the grid that you can count the spaces, so we're going to actually have to find each one of these. Okay, so let me change colors here. I'm going to try to make right triangles where we can actually count the different, oh, you know what? We just learned the distance formula. Let's do that instead. Let's find the distance of AB using the distance formula. Ready? So let's do distance of AB. All right, so let's start with the formula. x2 minus x1 squared plus y2 minus y1 squared. And by the way, I was about to do the Pythagorean theorem by making right triangles. You could do that. That is a method that would work. All right, so I'm going to talk about A and B. I'm going to label this x1, y1, and x2, y2. Okay, so let's substitute in. So x2 is going to be 1 minus 4. And we're going to do y2, which is going to be 4 minus 1. I think I did that wrong. Let's try that again. y2 is 4, y1 is 3. Okay, so let's do the subtraction first. 1 minus 4 is -3. 4 minus 3 is 1. So when you take -3 squared, you get 9 plus 1. So this is the square root of 10. Oh my goodness, I can't read that. Okay, so I'm going to just go label that on the graph. So that's the square root of 10. All right, so I want to fit all of this in one spot, so let me just make this a little smaller. Okay, so now let's go and do BC. Okay, so we're going to find the distance, again, of BC using the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. Okay, so I'm going to erase this up here, and I'm going to relabel this. I'm using points B and C, so let's call this x1, y1, and this one x2, y2. All right, so I have the square root of x2 is -2 minus x1, which is 1, y2, which is -5 minus 4. Let's do the subtraction. So -2 minus -1 is -3. I'm sorry, -2 minus 1 is -3. -5 minus 4 is -9. Remember, you can do that in the calculator. So -3 squared is 9. 9 squared is 81. So add that together, you get the square root of 90. So this one over here is the square root of 90. Again, I'm going to just make this a little smaller so I can fit all of this. Okay, last one we need to do is AC. So distance of AC. Start with your formula. So x2 minus x1 squared plus y2 minus y1 squared. All right, so I'm going to erase these up at the top again, and I'm going to label my A and my C. So x1, y1, x2, y2. All right, so let's replace our variables. x2 is -2. x1 is 4. y2 is -5 minus 3. Let's do some subtraction. So -2 minus 4 would be -6. And then -5 minus 3 is -8. So the -6 squared is 36. -8 squared is 64. So I'm going to add those together. 36 plus 64 is 100. Now the square root of 100 is 10. So this side right here is 10. Okay, so now we have, let's undo that. I got that part in. I just want to make it actually, I don't need to make it a little smaller. You can keep it just like that. All right, so the question says, is it a right triangle? So now that we have all three sides, we can use the Pythagorean theorem to see if it actually works. So I am going to find the largest side. Okay, now 90 is between 81 and 100, so that means the answer would be between 9 and 10. So that's actually smaller than the 10. So I'm going to call 10 as my C. My A and B don't matter, so I'm just going to label one of them A, one of them B. All right, so what we're going to do is we're going to take A squared plus B squared equals C squared, and we're going to substitute those numbers in to see if it actually works. So I called A the square root of 90. I called B the square root of 10, and C squared was 10. Now remember, when you have a square root, you are squaring a square root that cancels out and you're left with just the number 90. Same thing with this, you're left with just 10. Now 10 squared is 100. 90 plus 10 is 100. Is 100 equal to 100? Yes. So yes, this is a right triangle. The Pythagorean theorem does work. All right, example 4. Find the distance between the movie theater and the Gold Club. So we have a whole list of places. We're talking about, I'm going to just highlight this. We're talking about the movie theater, this dot right here, and the Gold Club. So I want to know the distance between the two. So quickly, I just want to label that the Gold Club would be the point 0.04. The movie theater is at -3, 3. So I have the 2 points. I'm going to use the distance formula. So the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, I'm going to call the movie theater x1, y1, and the golf club, one says golf, one says gold. Okay, I'm assuming the golf club is going to be x2, y2. All right, so x2 we just labeled as 0 minus x1, which is -3. y2 is 4 minus 3, which is also squared. All right, so let's do subtraction next. 0 minus -3. Now that's going to give us +3 squared. Plus 4 minus 3 is 1. So 3 squared gives us 9. 1 squared gives us 1. So add those together. 9 plus 1 is 10. Now this does not tell us to round at all, so I'm going to leave my answer as is. All right, part B says find the distance between the aquarium and the restaurant. So here's the aquarium. I'll do this in green. Here's the restaurant. Okay, so we're going to call the aquarium, well, let's figure out what the point is first. So that's 1, 7. We'll call that x1, y1. And the restaurant is at 4, 4. We'll call that x2, y2. All right, so we're going to use the distance formula. So D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so x2 is going to be 4 minus x1, which is 1. We're going to square that, plus y2 is 4. y1 is 7. All right, so let's do subtraction next. 4 minus 1 is 3. So 3 squared plus 4 minus 7. Now that's actually -3. Make sure you have parentheses around that. All right, let's square them. 3 squared is 9. -3 squared is 9. Let's add them together. 9 plus 9 is 18. Again, it doesn't say to round, so we will just leave our answer as is.